Okay, so with this question, we've got the cosine rule and the sine rule mixed in. So this question is relatively straightforward for one that has two things mixed in, but it's a good way to get us going, and then we move on to a more challenging question. So with this, in the triangle XYZ, XY is equal to 22, which is given, we know that. YZ is equal to 15, we know that. And the angle XYZ is equal to 74. So the angle XYZ is equal to 74. So what we're going to do is we're going to look at it. We know we're dealing with trigonometry. So this is the framework that we use for leaving cert trigonometry. The question asks us to find xz, right? So find xz. So that's the length of this here. And I'm just going to put that down as x, right? So I'm just going to put that in as x for now. And the reason why I'm putting that in as x is because that's the unknown that we're looking for, okay? So what I need to do is I need to go through the framework. Angles in a triangle adding up to 180 degrees will not affect this question because I don't know these angles, so I'm not able to find the other angles, okay? So a 90-degree triangle, we don't have a 90-degree triangle, or we can't assume that we have a 90-degree triangle, so we can't use Pythagoras' theorem, and we can't use trig ratios, okay? The next one is the area of a triangle. We don't know the area of the triangle, so in this case we can't use the area of the triangle to help us, so that's of no use to us. The next one there is the sine rule, and I need to think, can I use the sine rule to find this unknown side? So I could pair the two of them together, and that would be one fraction in my sine rule, but I need to be able to pair another side with an angle, and I don't have a side and an angle there, and I don't have a side and an angle there, so I can't use the sine rule. So in this case, I would need to use the cosine rule. The other thing is, when you're using the cosine rule, you need three sides and then angle, okay? So in this one, I'm going to have to start off by using the cosine rule. So the cosine rule says that a squared is equal to b squared plus c squared minus 2bc cos of a. Okay, so what we need to do is we need to look at it and we need to label our triangle. So the first thing that we need to do is we need to be able to label the triangle. So when I say label the triangle, the most important thing is that we label the angle as A. So I'm going to label the angle there as capital A. Okay. The next one that I label is the side that's opposite capital A, which in this case is X. And then B and C, it doesn't matter what order they're going in. So I'm going to put B and C from left to right. Okay. The next step is just to fill in what you have. So I'm going to fill in what I have there. So instead of A squared, I'm going to say X to B squared is equal to, instead of B, I'm going to put in 22 to B squared, plus, instead of C, I'm going to put in 15 to B squared, minus 2 times B, which is 22, C, which is 15, and cos of A, which is capital A, which in this case is 74. So you just need to double check that. So B was equal to 22, C was equal to 15, B was equal to 22, C was equal to 15, and cos of A is cos of the angle, which in this case was 74. Okay. Now you need to be able to simplify that. So how we do that is we'll just say that x squared is equal to, instead of 22 to be squared, I'll write in 484. And I got that just by typing it into the calculator. 15 squared is 225. And now what I'm going to do is I'm going to tidy up this here. So I'm going to tidy up all of this. Okay. And when I tidy up all of that, I get 2 times 22 times 15. And that gives us minus 660 cos of 74. Okay. The next step again is just to tidy that up even further. And if I'm going to tidy that up even further, what I'm going to do is I'm going to tidy up these. They can go together, can't they? So x squared is going to be x squared equals 484 plus 225 gives us 709 minus 660 cos of 74. Now, the reason why I'm doing this is just to do step by step, because when these are being marked for the leaving cert, there is questions going for getting to this step, you could say. So it's important that you don't just type this straight into the calculator, because if you made a mistake typing that into the calculator, you'd lose all the marks. So like this question could be broken down into maybe 3 different levels. So you would have got marks for subbing in the values correctly, you would have got marks for getting as far as here, and you would have got marks for getting the final answer. So if you had made a mistake with the first line, and if you worked it out showing your workings like this, then you'd still get the majority of the marks. Whereas if you had made a mistake with the first line, and if you had just wrote down an answer, then you would lose all the marks. Okay, so it's very important that you write down the steps as you go, right? So what I'm going to do now is I'm going to just simplify the right hand side of the equation. And to simplify the right hand side of the equation, all we need to do is type it into the calculator. So x squared is still x squared. X squared is equal to 709 minus 660 cos of 74. And that gives us 527.0793452. Okay, so far that starts telling me what x squared is equal to. I don't want x squared, I just want x. So in order to find out what x is equal to, I need to get the square root of that. Okay, so the square root of that will give me 22.95820867. So x will be equal to 22.95820.867. So far what I've done is I found the value of A. Okay. The next part of that question, part 2, asks me to find, well, it says correct to near centimetre, so I'm actually going to fill that into near centimetre, and to near centimetre, my answer there will be x is equal to 23. Okay. So that's the first part of that question done. So for part 2 of this question, we need to look at what we're looking at here again. We need to try and work this out. So it says find the angle yxz. So from y to x to z. Okay. So find the angle here. We need to look at the framework of how we do things, and we need to decide what we're going to do, right? So to find this angle, okay, I'll just get rid of that for a second. So to find this angle here, we're going to call that angle y for now, just so you can see what's happening. So we'll call that angle y. So we'll go through the framework. So angles in a triangle adding to 180. That won't help us yet because we're looking for this angle, but we don't know this one. The next one is 90 degrees triangle. So there's no 90 degrees in this, so we can't use Pythagoras' theorem, we can't use trig. The area of the triangle, we don't know the area, so we can't use that. The next thing we have there is the sine rule. So I need to look at this and think, can I use the sine rule? So I have an angle, and I now have a side, so I know an angle and a side, so that could be one fraction. The second fraction has to be an angle and a side. I'm looking for this angle, and I have this side, so I can actually use the sine rule in this case. Okay, so in this case, you can use the sine rule, we've established that, but if you wanted to, you could use the sine rule, or the cosine rule, because you have 3 sides, and you're looking for an angle, so you could actually use the cosine rule as well. But if it were me, I'd use the sine rule, because I think the sine rule is slightly easier than the cosine rule. So we'll do the sine rule here, and the sine rule just says that a over sine A is equal to b over sine B. So I'm just going to do that. A over sine A is equal to b over sine B. I'll actually just bring that down a small bit because I want to just draw a sketch of that just to keep it tidy. So if you want to draw a sketch of that, just so you can label what you have. So if we draw a sketch, we can just label what we have and what we don't have. It makes it easier. So we have 74, we have 22, we have 23, and we have 15. And we're looking for y. Okay, so the reason why I sketched this is just so I can label what I have. So when I'm doing the sine rule, what I'm going to do is I'm going to pair these two together. So those two that I'm going to pair together are going to be these two. So the angle and the opposite side. and obviously the other two I'm going to pair together are the angle and the opposite side. So from that you can see that the 74 and the 23 are going together, and the y and the 15 are going together. And what I need to do is I need to put them into the equation, and I'll try and keep all my unknowns on the left hand side. So if I want to keep my unknowns on the left hand side, I need to put the pink ones into the first fraction. So the side there is obviously going to be 15 over sine of the angle, which is sine of y. And that's going to be equal to the green ones, which is 23 over sine of the angle, and the angle is 23, or 74 even. Okay, so what we're going to do is we'll cross multiply. We'll multiply, we have a fraction equals a fraction, so we can cross multiply. Okay, and we can do that. And what I like to do is keep all of the unknowns on the left hand side. So I'm going to keep all the unknowns on the left hand side. So I'm going to do the red ones there on the left hand side and say that 23 sine y is equal to 15 sine 74. Okay, so in order to solve this, I now need to get rid of the a couple of steps left. I need to get rid of the, just move them up just slightly. I need to look at what I have here, which is 23 sine y, and I need to get rid of the 23. And how I do that is I divide both sides by 23, and I'll be left with sine y equals 15 sine 74 all over 23. Okay. Last thing I need to do is I need to get a value for y. And to get a value for y, I don't want sine y, I just want y. So to get a value for y, I need to get the sine inverse of the left hand side. 15 sine 74 all over 23. Okay, if you type that into your calculator, shift sine, and then put in your fraction button, put 15 sine 74, close your brackets, all over 23, close your brackets, and you will get an answer of 38 point. I'll just put that in there. So y is equal to 38.8224991. So the answer it asks for correct to the nearest degree. So correct to the nearest degree will be 39 degrees. Okay. So we'll just move on there and look at question 12. So question 12 is this one here. Again, we've got triangles. So if we see triangles, we will automatically think of trigonometry. And trigonometry, we look at angles in a triangle, we look at Pythagoras' theorem and so on, right? So what we're going to do is we're going to start there by looking at the first one, right? So the length of AB, so the length of AB is what we're looking for here, and we need to look at this and see if any of this helps us. So what we'll do is we'll start off with the very first one, which is angles in a triangle equal 180 degrees. So what I can do is I can find out what the angle there is. So I can find out what the angle here is because I already have these two angles. So I'm going to fill that in, right? So that angle there is going to be 180, take away 23, take away 33. Okay, so 180, take away 23, take away 33, leaves you with 124. So 124. Okay, so 124 degrees. So you can see that there, and I've put that in, so you should be able to see that there. Okay. Can I use that any place else? So angles in a triangle equal 180 degrees. I can't use that any place else because I don't know the lengths of these sides. And it doesn't say anything about these signs being equal, so I can't do anything else with that, right? The next one that I need to look at, there is a 90-degree triangle. So we don't have any 90-degree triangles, so we can't use Pythagoras' theorem, and we can't use trig ratios. The next one is the area of the triangle. It doesn't mention anything about area in the question, so I can't use anything to do with the area of the triangle to help me. So the next step we come to is the sine rule. Now again, think about what we're looking for. We're looking for the length of AB. So we're looking for the length of AB, which is this length here. And I need to think, can I use the sine rule to find that length? Okay. Now, can I use the sine rule? I'll just sketch that out so you can see it. So this is AB. So we'll just put that in. This is 4. This is 1, 1, 0. This is B. This is A. This is C. And we don't have any other information, so I can't actually use the sine rule in this case. So let's see. Oh, there's 5 there. Sorry, Eggman. So we put the 5 in, and we actually can use the sine rule. So, all right. So, well, actually, we can't. So we can't use the sine rule because if we're using the sine rule, we'd have to use the angle and the opposite side, and we'd have to use an angle and an opposite side, which we don't have an angle here, and we don't have an angle here, so we can't use the sine rule. So in order to find out what this one is, we need to use the cosine rule. So we'll just label this x, and in this case we can use the cosine rule because we have 3 sides and an angle. Okay, so we'll use the cosine rule, we'll solve that and get an answer for that. Okay, so the cosine rule is a squared is equal to b squared plus c squared minus 2bc cos of a. Okay, so we'll label what we have. A is obviously the angle, so lowercase a will be opposite the angle. It always is. And b and c doesn't matter. I'll just go from left to right, b and c. Okay, we can fill in that information. So a is going to be equal to x to be squared is equal to b to be squared, which is 4 to be squared, plus c to be squared, which is 5 to be squared, minus 2bc, so minus 2 times 4 times 5 times cos of the angle, which was 110. Okay, so you can see all them, and you can see how they link back in. B was equal to 4, so B was equal to 4, C was equal to 5, C was equal to 5, B was equal to 4, B was equal to 4, C was equal to 5, C was equal to 5, and cos of the angle A is going to be cos of 110. So I'll quickly just go through that and we'll solve that quickly because you should be okay with the actual mechanics of this. So 4 squared is 16, plus 5 squared is 25, minus, let's just look at this, 4 times 5. So I'm just going to do this in my head. 4 times 5 is 20, 20 times 2 is 40. Okay, so that brings on to the next part, which says that x squared will be equal to 16 plus 25. So 25 plus 10 is 35, 35 plus 6 is 41. So 16 plus 25, just make sure we're getting these right, minus 40 cos of 110. So at this stage, this represents a number, this represents a number, and I can type that into the calculator and I'll find out what x squared is equal to. So x squared will be equal to 41 minus 40 cos 110, close your brackets, and that gives you 54.68080573. So to find out what x is, I need to get the square root of both sides. So I need to get the square root of all that. And I'll just do that now. So the square root of that, and the square root of the answer gives us 7x is equal to 7.3946471, and they wanted that correct to 2 decimal places. So if I'm going to go to 2 decimal places, I can go back 1, 2, draw a line, and that 4 will cause that to round off. So my answer for the first part, the length of the side AB is equal to 7.39, and that is centimeters. Is it centimeters? There's no unit, so I'll just leave it as that. Okay, so that's the first part of that. You can see how these questions are going to be a little bit more challenging. It's not that they're any bit more challenging, it's just that you need to be able to unpick them yourselves, right? So that'll bring us to the next part there, which is this question, and we have to find the length of CD. So the length of CD, and I'm just going to put that in there in, or I'll put y in actually because we used x already. So y is the length of CD. So anytime again we're doing questions to do with triangles, we know we're dealing with trigonometry. So we're going to look there at how we deal with trigonometry. We're going to start by looking at the triangle that we're given. Does it have angles of 180 degrees? So does it have angles of 180 degrees? So the angles there add up to 180 degrees, so that's not going to affect us for this. A 90-degree triangle, we don't have 90 degrees here, so it's not going to be Pythagoras' theorem, it's not going to be trig ratios. The area of the triangle, we don't know the area of the triangle in this case, so that's not going to benefit us. So the next thing we're going to look at there is the sine rule. So I'm looking for a value for y, and in this case I can use the sine rule because I've got a pair, an angle opposite a side, and I have an angle opposite a side. So I'm just going to highlight them so you can see which ones we're dealing with. So the green ones, we'll say, will be going together because they're opposite. And the pink ones will be going together. So the pink ones are going to be going together because they're opposite. So in this case, we will be using the sine rule. So the sine rule is a over sine A is equal to b over sine b. So we have that there. Okay, now we just need to fill in what we have. And like I always say, I always put the unknowns in the first fraction. So the unknowns in the first fraction, the side there is y over sine A, which is sine 124. And that will be equal to b, which in this case is 5 over sine 23. When I have a fraction equals to a fraction, I need to cross multiply. So I said to you before, and I'll say it again, I always like to keep the unknowns on the left-hand side if I can. So I'm going to multiply the blue ones first. So that will leave me with y sine 23 is equal to 5 sine 124. The next step here is to try and get y by itself. So in order to get y by itself, what I need to do is I need to divide both sides by sine 23. So that will leave me with y equals 5 sine 124 over sine 23. That will leave me with 10.60879864. It asked me to find the length of CD, and it said to give your answer correct to 2 decimal places. So we'll go back to 1, 2, draw our line, look at the number that follows, which in this case is 8, and that 8 will cause that 0 to round up to 1. So in this case, because this is greater than 5, this needs to round up. So my answer there the length of CD is equal to 10.61 centimeters. Well, actually, there's no units, so it's just 10.61. Okay, I'm going to highlight that.